Glass type prediction is a machine learning task that involves identifying the type of glass based on certain characteristics such as the glass's refractive index, sodium content, and magnesium content. Different types of glass have different properties and uses. For example, tempered glass is used for car windows, building windows, and tableware, while fiberglass is used for insulation and reinforced plastic. In R, there are several libraries such as Caret, Random Forest, GLMNet and XGBoost that provide functions to train machine learning models for glass type prediction. The process of building a glass type prediction model typically involves the following steps: collecting and cleaning the data. This includes acquiring a dataset of glass samples and relevant features such as refractive index, sodium content, and magnesium content. Exploratory data analysis. This includes visualizing and understanding the relationship between different features and the outcome of interest, classifying the glass type. Pre-processing the data. This includes normalizing, scaling, or transforming the data to prepare it for the model. Choosing and training a model. This includes selecting an appropriate model, such as a logistic regression or a random forest, and training it on the pre-processed data. Evaluation. This includes evaluating the model's performance on a separate test dataset and comparing it to other models or to a baseline. Fine-tuning. This includes finding the optimal parameters for the chosen model using techniques like grid search or random search. It's important to note that glass type prediction is a well-established area of machine learning, and there are many models and techniques that can be used to improve the performance of the model. Additionally, it's important to use cross-validation to ensure that the model generalizes well to new data. The performance metric used to evaluate the model will depend on the specific use case. For example, in a manufacturing setting, it may be more important to have a high accuracy rather than high precision. Overall, using machine learning techniques to predict the type of glass in R can help to improve the efficiency of the manufacturing process and aid in the decision-making for the final use of the glass. It's important to use appropriate techniques like cross-validation to ensure that the model generalizes well to new data, and to use appropriate performance metrics that align with the specific use case of the model.